Sounds good. Okay, so welcome to the second module. So we are starting the second module, which will be split into two classes. So we'll be finishing or going up half of the module this class, and then we'll cover up the next part during our next session. Where I know this is again going to be basic stuff, introduction to computers and what and how and why we need these side things called computers and hardware and so on and so forth. So we'll be discussing briefly about all the hardware factors and input output devices and all the basic elements of a computer. And remember guys, you will get couple of questions from this module as well, where you have to define what is an input device, what is an output device, and there are some MCQ questions regarding this module as well. So that is something you guys need to keep in mind, but obviously this is really easy. So it's just a matter of remembering what is what, and that's it. Okay, super. So for today's lecture, the table of contents, we'll be going through the history of the computer, generation of computers, different types of classifications of computers, and then the major hardware components on what we basically have always basically what we need for a computer to work. So we'll start with the history of the computer. So the evolution of computers can be categorized into distinct generations. Okay, so each representing significant technological advancements, and there are multiple generations and so on and so forth. So let's explore the first to fifth generations of computers, understanding their essential characteristics and the contribution towards the computing history with their gradual improvements. So start off with, now here we are starting from with the early stages and we are going forward to the current generation which we have. So the first point. Now, I hope everybody must have seen this, right? So this is called an abacus. මං හිතනවා abacus එකක් හැමෝම දැකලා ඇති කියලා. මොකද පොඩි කාලේ අපි සෙල්ලම් කරන්න පාවිච්චි කරනවා ගණන් හදනවා හැමෝම මේකෙන් එහෙට මෙහෙට කරලා තමයි ගණන් ටික හදන්නේ. So this is technically at a machine which will let you calculate, right? So this is kind of like a calculating machine. So this is actually a computer, right? So you feed in some data and that will show you a representation. You guys can see in this video, ඔයගලන්ට මේ වීඩියෝ එකේ පේන ඇති මේකේ තියෙනවා parts දෙකක්. abacus එකේ තියෙනවා උඩ පොඩි beads ටිකක් තියෙනවා. එතකොට මේ beads ටික move කරාම ඒ beads වලින් තමයි calculation එක හදන්නේ. So you move the beads according to the number of items you want to calculate, and then you count the number of beads, and then that means you will be able to perform the calculation. So this is basically the earliest stages which we can track back, where we had the utmost basic computing or basic device where we were able to do some calculations. So this is like before 1450. Okay, so it's like long time before. And then this was actually upgraded by in the 17th and 18th century, so that it was actually one of the stepping stones. Then we get into the first generation. Okay, so this is the first generation of computers. As you guys can see, this is actually a and very old computer in the background. So this is the birth of modern computing, right? So the first generation of computers emerged in 1940s, utilizing these things called vacuum tubes as the primary electronic component. So I'm not sure whether you guys know what is a vacuum tube is. Vacuum tube එකක් කියන්නේ අපි දැකලා තියෙනදී ඕලන් දැකලා තියෙනවා අර filaments තියෙන normal bulbs තියෙන shooty bulb එක. So a vacuum tube is almost similar to a bulb. Same concept. Plus එකක් තියෙනවා minus එකක් තියෙනවා minus එකකින් plus එකට current එක යනවා. So that it will based on the current and the direction, it can either work as a switch or it can either work as a amplifier, so that that signal can be amplified, or the signal can be used as a switch to perform some sort of a calculation. Okay, so that's the basic component of a vacuum tube. ඔය පරණ amplifiers වල තියෙනවා අවුරුදු ගානකට ඉස්සර ආවා ඔය මේ ලොකු ඔයගලන් දැකලාද ලොකු amps තියෙනවා විශාල box එකක් එක්ක තියෙන full size amps. Most of those amplifiers also had vacuum tubes. So that is actually one of the reasons those amplifiers are like extremely expensive. Now I think we have like vacuum type devices still available, but those are kind of like collector's material and that belongs to the retro scale. So using these vacuum tubes as the primary electronic component, the first computer which was released called ENIAC, which is known as Electronic Numerical Integrate and Computer. So this was actually kind of like a big machine which required at least about 10-15 people at a time to control it. And these machines were like extremely huge, and it consumes a massive hell of a lot of power, because the reason is because all these small vacuum tubes were there, it literally consumes power. So I will share you guys a link from a channel called Vertasium. Vertasium, let me share it right now itself so that you guys can literally watch it later on. So he did a video about this. Let me send it. I'll put it on the chat. So remember to check this out. So this is a video where he explains how Nikola Tesla and how these telephones and things were invented, and he goes through the concepts of how Thomas Alva Edison came up with the bulb, and then accidentally he found out that scientists found out that that particular bulb can be used as a transistor, and how it became a vacuum tube. So I was going to attach that into the lecture, but then we are technically going more in depth into that particular technical scope. So I have shared that video in the link of our WhatsApp group. Remember to go through it, because it will give you a clear idea about what this is. Okay, super. So this was in 1950s, so 1940s to 1950s. And then we get into the second generation of computers, which is the point where this huge vacuum tubes got replaced with transistors, where people found out that transistors can be like created in small sizes, and then scientists evolved the same concept of a vacuum tube into a small device where it completely replaced the vacuum tube architecture. So transistors were really small, more reliable, and it generated less heat. This heat part, remember to watch that video. ඒ වීඩියෝ එක බලන්න. ඒ වීඩියෝ එකේ YouTube explain කරනවා කොහොමද මේක heat එක එන්නේ, how this vacuum tubes literally work when it comes to a normal computer. So remember to watch that. It will obviously give you a clear understanding of that part. So the second generation computers basically use these transistors, and then they were also able to save data. So earlier, what happened was, now when we were looking at these old computers, like these monolithic computers, they were basically there for just data processing. So you were able to select a set of conditions, and then when you run the conditions, it will automatically process it, and it will give you an output. But what happened was, when it comes to when the transistors were introduced, and the second generation computers, scientists were able to literally use a thing called a punch card, and, as we know, magnetic tape for data storage, where we were able to actually save some data. So we'll see. I'm not sure whether you guys know what is a punch card is. So because of that reason, I added a video so you guys can see this. So what you see here is, it's kind of like a kind of like a data set. So what you guys can literally see is stored data. Okay, that is how at early stages, like during the second generation of computing, this is how people saved data. So it was literally, so you take a card, and in that card, you have a set of numbers mentioned, like it can be binary numbers, so it can be a number sequence. In that number sequence, you literally punch it. You punch the card, and then you feed it into a reader, where that reader literally reads these empty spots, and it will convert that as an instruction set. So these punch cards were used for multiple reasons. It was used to create programs, like write programs, and it was created to basically save stuff as well, like save instructions and so on and so forth. So පටල ගන්න එපා. පංච් කාඩ් කිව්වම අර මේ අපි සාමාන්‍ය මනුස්සයා කියනවා අර attendance mark කරන්න punch card එක. ඒකට කියන්නේ punch card කියලා. Now it's not actually being used anymore, but still there are companies and government institutions where you need to pull out your card from a card holder, put it inside the punching machine. The machine will punch it, and then that will basically print the time, the in time into the card. That is also known as a punch card. පටල ගන්න එපා ඕක දෙකක්. මේ 1950 ගණන් වල punch card කිව්වේ මෙන්න මේකට. Okay, super. So then the third generation. Now we are in the the time period between 1960s to 1970s. This is the time period where we basically we had a big leap when it comes to computing, and we had a big leap of integrated circuits, and computers became faster. So this is where people or scientists were able to create a thing called an IC, an integrated circuit. So that was kind of like, what happened was, people used transistors. So transistors were being used for everything. And then people, or the scientists, found out, like, why can't we put multiple transistors in a miniature circuit? So they tried it out, and it worked. So what they did was, they got a set of transistors and created a small circuit, and then they were able to manufacture an integrated circuit chip where it will contain a set of transistors. So this is something which I explained you guys during one of my previous lectures, where I said that there are multiple transistors within a CPU and how these CPU systems work. So we'll get to that in a later stage. So IC significantly increased the computing power. computing power and it reduced the size, and obviously it lowered the cost as well. So that was the starting point of all the computing as we know right now. And then at this moment, we had another breakthrough where now, since these integrated circuits became smaller, and since people were inventing more circuits and more systems and all, people need to, developers had to develop multiple languages, programming languages, in order to utilize these new changes, right? So because of that reason, we were introduced with languages like COBOL and Fortran, so that we were able to write hardware specific coding, and all these new computers came to be. Okay. So then we go to the next stage where this is the fourth generation, which is the point where we were introduced with the microprocessors. So 1970s to 1980s. I was lucky enough to have a computer called back in the day. My father had a computer called Sinclair. So the Sinclair computers were actually invented somewhere like the concept was invented somewhere in 1980s. ඒකට tape drive එකක් දාන්නේ. චලක් විතර keyboard එකක්. Computer එක keyboard එකක්. And you have to plug that into the TV. TV එකට plug කරනවා. TV එකට plug කරලා, so back in the day we had a black and white TV. And I think black and white TV එකට plug කරලා you have to TV එක tune කරන්න ඕනේ. Tune කරාට පස්සේ you have to put a small tape cassette. So it's kind of like a memory chip. ඒ කාලේ memory chip කියලා දෙයක් තිබුණේ නැහැ. So it's kind of like a small cassette. So you have to put the cassette into the piece computer, and then only it starts working. Okay. So Sinclair and all, they were actually the pioneers when it comes to the fourth generation of computers. So back to the slides. So the fourth generation of microprocessors. This is when the microprocessor was actually created, where it was kind of like a collection of ICs, collection of integrated circuits put into a single chip, where it had multiple different levels of processing components together. Okay, so microprocessors such as Intel's 8086 and Motorola's 68000 literally fueled the rise of personal computers and brought computing to the masses. Motorola, Motorola again a microcontroller company. They were into networking and mobile devices and so on and so forth. But mainly these guys were literally a company who built microcontrollers back in the day. So they created microcontrollers for almost every peripheral, like multiple devices, robotics, and so on and so forth. So that's why these guys were like really in the market. And Motorola and Intel were the pioneers who started building these type of CPUs. And since the CPUs were there, they were able to process multiple components, or multiple instructions at a time, right? That is when the concept called a graphical user interface was invented. And operating systems like MS-DOS and Apple Macintosh systems were basically released during that time frame. And it gave the PC its own name. Say it's the point where the PC, the personal computer, was invented. So earlier back, when it comes to the second, third generation of computers, mainly computers were used by governments for military things, trying to send rockets to the moon, and so on and so forth. People did not had the luxury to have their own personal computer. But when these microprocessors were invented, and it automatically, when the prices went down, companies like Intel and Apple and Microsoft and IBM and all these companies were able to create miniature computers, like not like huge mainstream computers, and they introduced that into the market. That is when the personal computer was invented. I highly recommend you guys to watch the movie Steve Jobs. So if you watch that movie, Steve Jobs movie ka බලන්න පුළුවන් නම් ඒ movie එකේ, so if you really have the passion to become a software engineer, that's a movie you must watch, because that movie captures all these historical points. It basically starts from the early ages of Steve Jobs, where he was in the university, and how he dropped out, and how he started his first computer, how he started his first computer business, getting this Motorola chips and trying to build his system on top of it. So that's a movie which you guys really need to watch. So obviously remember to put a reminder for that. Okay, super. So we were discussing about the 4th generation, and then now we have the 5th generation, which is the current era of computing. That is after 1980s. Okay, so the 5th generation of computing introduced significant advancements in artificial intelligence, AI, and in parallel processing. Obviously, expert systems like natural language processing, machine learning became the key areas of research and development, as well as we all know modern computers utilized advanced processors, solid state drives, which is faster storage, as well as it uses cloud computing to enhance performance and connectivity. So I'll just explain you one specific point here. So this parallel processing thing, that is actually something which the typical සාමාන්‍ය සිංහලෙන් කියනවා සාමාන්‍ය ජොකියා දන්නේ නැති දෙයක් ඒක. Parallel processing කියන්නේ, then if you take your phone and if you take a picture, at the time when you move your phone, hundreds and thousands of processing cycles has to be done every time you move your phone from one place to the other, because the camera literally takes in all the data and it automatically real time processes the data, and then when you press the shutter button එක press කරපු හැටි, I'm talking about a flagship phone නේ. ඒ කියන්නේ normal අපි Samsung නම් S series phone එකක්, Apple high end phone එකක්, Apple නම් normal phones එකක් තියෙනවා, Apple Samsung S series, Samsung A series, නැත්නම් මම දන්නේ ගොඩාක් Chinese phones වල මේ features ටික අඩුයි, but still they do have it up to a certain extent. When you take a picture, what it does is it parallelly takes multiple pictures at a time, and then it processes each photo, and it has its own AI algorithm, a neural algorithm. ඕගොල්ලන් අහලා තියෙ Apple කියනවා neural engine කියලා කතාව. That's the machine learning algorithm they have. So all these algorithms work seamlessly together, and then it takes the picture and show you the update or the taken picture as a preview. The fun part is all these things happens within couple of seconds, or like within couple of microseconds, because it accesses the camera, it takes the data, processes it, color grade it. Now in Samsung and Google Pixel phones, they have like a massive processing system. In Google Pixel, they don't have enough cameras as well, but their artificial processing is next level compared to Apple and Samsung. Still, they have the best processing. All these things are done parallelly using this new micro architectures, control architecture. Okay, so we'll get into parallel processing later on, where we will be discussing the different types of computers and clusters. So now when we came through the history. Now we have a small blocking point. We need to understand what is a transistor. So, මොකද්ද මේ කකුල් තුනේ චුටි කෑල්ල? චුටි part එක. Transistors, literally, it's a small device where it will control the flow of electricity. Then හිතන්න simple විදිහට, because when we are getting into logic gates and the circuit part, we will go through this in depth and we'll understand how this works with some circuit diagrams. And මම ඔයගොල්ලන්ට circuit diagrams ටිකක් දාලා පෙන්නන්න කොහොමද මේක වෙන්නේ කියන එක. දැනට just understand what this is. Okay, so just think a transistor as a small switch where you have the switch which will connect or disconnect a circuit. Okay, so we'll see how it works. So just imagine you have a light switch in your room. Okay, so when you turn the switch on, automatically, as you can see in this demonstration, the bulb lights up, right? And when you turn it off, it automatically goes off as well. So a transistor is kind of like a tiny switch, but it works with electricity instead of controlling the light bulb. The main circuit එකේ වෙන්නේ ඔයා switch එක on කරාම circuit එක on වෙලා light එකට current එක යනවා. But a transistor, what it does is it does not control like actual electricity, but what it will control is a switch within a small circuit. So it's a small electronic component that can control the flow of electricity in a circuit. If somebody asks you what is a transistor, that's the most easiest answer to write. So it has three parts. Make it an important point again. It has the emitter, the base, and the collector. Okay, කකුල් තුනක් තියෙනවා. Emitter එකයි, base එකයි, collector එකයි. So we'll see what these three items do. So get to the next slide. So imagine, just think that it's kind of like a water pipe. So when the transistor is on, එක පැත්තක් on වෙලා තියෙනවා නම්, that means it allows the flow of electricity from the emitter to the collector. E එකෙන් C එකට current එක යනවා. Just like turning on the light switch allows the electricity to flow to the light bulb. ඒක on වෙලා තියෙනවා, ඒක දිගේ යනවා. The base of the emitter is like the control button. So when you press the control button, it determines whether the transistor is on or off. Okay, so pressing the button allows the electricity flow to flow through the transistor, or it will just like flipping the switch on or off. When the transistor is off, it stops the flow of electricity from the emitter to the collector, like it's turning off the light switch to control the electricity from reaching the bulb. simple විදිහට කියනවා නම් E එකෙන් C එකට current එක යනවා. emitter එකෙන් collector එකට කොහොමත් current එක තියෙනවා. ඔයාගේ base එක තියෙනවානේ. base control එක. base එකෙන් තමයි කියන්නේ මේක active ද නැද්ද කියලා. එතකොට base එකෙන් පුළුවන් ඕක off කරන්න. base එකෙන් off කරොත් ඒ circuit එක කැඩිලා. base එකෙන් on කරොත් ඒ circuit එක on. Simple as that. ඉතින් ඕකෙන් තමයි that is how you switch multiple items together. Okay, we will go in depth about transistors when we get into diodes and this calculation part, because here it's just a matter of for you guys to get a simple idea. But in order for you to get some hands-on experience, you need to try out some data, like a proper circuit diagram. So then that would be easier. Do some research. මේක ටිකක් කරලා බලන්න. මොකද transistors වලින් ගොඩක් දේවල් කරන්න පුළුවන්. කියන්නේ transistor එකක්, either you can use the transistor as a switch or you can use it as an amplifier so that it can amplify the signals. So you have both these options. I hope you got the point, and we'll get to the next point. So now we discussed halfway through about the type, the generations, and we briefly discussed what is a transistor. Now we are getting to the different types of classifications of computers. So in simple terms, types of computers. Okay, so computers come in various types, each designed to serve different technological, functional, and size related requirements. Technological requirements functional requirements size එකකින් requirements උත් වෙනවා. Size in the sense අපි බලමු මොකද්ද size එක කියන්නේ කියලා. Okay, so first we'll go through the types of computers based on the technology. Okay, so guys, remember these type of computers will have a question. There are multiple questions where they ask what are the types of computers and all. So remember these terms. I share the slides with you as well. And we will obviously go through this when we are going through the paper class for sure. But just keep in mind and remember these terms. Analog, digital, computers are නම් ටික මතක තියාගන්න. මොකද ඔක අනිවාර්යෙන් question එකේ එනවා. So we have the analog computers. These are the first type of computers where it uses a continuous signal to represent and process data. And in simple terms, ඔයගලන්ට මතක ඇති මම අපි කලින් කතා වුණා data gather කරනකොට we discussed about a point where when you're gathering data from like real world data, like from a weather balloon or from a buoy located at a specific location in the sea. So we discussed that when you are gathering these data points, that data is basically gathered from an actual event, right? Example, weather balloon එක උඩට ගියාම ඒකේ sensors තියෙනවා. ඒ sensors වලින් දැන් තියෙන weather එකේ condition එක capture කරනවා. Same like that, if you take a sea buoy, which is located at some point of somewhere in the sea, when that moves, then automatically that data set is being saved, or that data set is being recorded into the computer. So when it comes to capturing analog data, you need to have an analog computer where it will basically capture an analog input. Okay, so digital input, we all know it's the digital stream of data, but here it will be a different signal, and it's going to be a continuous signal so that it will represent data in a different way. So that is about analog computers, where you basically used to capture some actual data. And then we have the digital computers, where, as we all know, this is basically being processed using the binary digits 0 and 1, also known as bits. They are the most common type of computers used today, from personal computers to supercomputers. Basically, that's the digital computers type. So digital computers are like versatile and can perform a wide range of tasks, from calculations and data processing and multimedia, gaming, whatever the things you do with your mobile phone or with your computer is and that falls under the type of digital computers. Then we get into these hybrid computers. So the hybrid computers are also something we have at almost everywhere, but we don't literally feel and see. So like hybrid computers, what they do is it kind of like a combination of both analog and a digital computer. So it utilizes analog technology for measuring and collecting data, and digital technology for processing and presenting information. So example, if we take a air conditioner AC unit. So it basically has an analog computer or an analog chip where it analyzes the room temperature and see or analyze what's the temperature the user has been set it to, and then it sends a message to the digital computer, which is the chip inside, saying that, okay, මෙයා set කරලා තියෙන්නේ 26ට, එහෙනම් 26ට අපි මේක cool කරමු. Then automatically the digital computer will send a digital signal to the whatever the compressor or the device which is trying to cool the place up, and that will start cooling. So it's kind of like a mixed system. Example, again, the best other example is if you take a car like Tesla or something. So Tesla, the car is again kind of falls into the category as a hybrid computer because it has sensors where it will process analog signals like distance and spatial awareness and so on and so forth. And then it automatically converts it into a digital signal, and the digital computer helps you process it and give you a clear output. And end of the day, it will keep you safe. So these are the things called hybrid computers. So keep in mind, hybrid computers, I think this is not there in your curriculum. I just put it because you guys need to know that as well. Okay. And then we have the PCs. So we all know personal computers are basically the typical computer designed for individual use. And it's primary for tasks like word processing, web browsing, multimedia, gaming, development, and so on and so forth. Remember this particular word, PCs are designed for individual use. Okay. So if somebody asks, if you get a question, define a PC or what is a personal computer, then the answer should be exactly a PC is designed for individual use, and you can define and explain what are the tasks which you can do with it. So the reason we use this as a separation is because we don't need, so computers falls under the same category, but then PCs and servers and server-side machines has to be separated into different categories. Because usually in ideal scenario, you will not use your PC to host a website, right? You will not use your PC to deploy an application. For that, you will obviously go for a server or supercomputer. Likewise. So back to PCs. So they come in various forms, including desktops, laptops, tablets, phablets, mini computers. And now we have this TV units, TV devices. Everything falls under a PC. And now basically this new Samsung phones also partially falls under a personal computer, where you have this, it's known as the Samsung DeX, where you have this small device where you can plug in the Samsung phone. And if you connect that into a display, then automatically you have the whole Office suite in your screen. So then you can start working on a Word document then and there out of the box. Okay. So that's the reason this particular thing is called a PC. So then after PCs, we have the workstations. Workstations, දැන් අපි ලංකාවේ නම් PC workstation කියන්නේ දෙකම එකයිනේ. අපි සිංහලෙන් කියන විදිහට. හැබැයි in actual terms, a workstation is a high performance computer used for some sort of a specialist task. So obviously it will require a substantial computing power, and anything which will require high computing power and some dedicated material. So simple terms. Now, let's say if you are a graphic designer, then you will have two machines. You will have your PC as well as you will have your workstation, right? So now in it depends on different cases. Now, this is so I'm currently on my primary laptop. So this is a heavy high-end M1 Pro machine, but at the same time, I have a small MacBook Air as well. So that is my PC. So this is my workstation. But the definition is different, but this consumes a lot of power, and this is extremely powerful as well. This machine I'm currently using, but my MacBook Air is kind of like a small machine where I used to create notes. I take it for my meetings and so on and so forth. Okay, so when it comes to workstations, remember workstations are focused towards high-end processing and extreme level, which will require some substantial computing power. So they are commonly being used by professionals in graphic design, video editing, engineering, and scientific research, and obviously development. Then we get into servers. So we know a server is basically, again, a computer, but it is a computer dedicated to managing and distributing network resources. So it's a computer which does not have a display or anything, but it's part of a network and you can access it through a network. So basically, in simple terms, they store, share data, host websites, and manages databases. Basically, it provides all the online services which we need from a server provider or from a server. So then we have the mainframe computers. So mainframe computers is, in simple terms, this is a collection of servers which will be created towards a specific reason. So it can be used by finance, government, scientific research, or any high reliability and security systems to basically provide a dedicated powerhouse to control their or to manage their processing part. So these mainframe computers, now still this is literally taken as a computer type of computers. But now with the new 21st century, we are not technically referring computers as mainframe computers now, because after the cloud computing came to be, people literally moved to the cloud. So earlier, what mainframes in the sense about 15 years ago, more than 15 years ago, we didn't have this kind of like a connected systems, right? So now everything is distributed. Example back in the day, I think this was about 20 years ago, where at that point we had the internet, but we didn't have the internet like as we have it right now. So it was really slow, and we couldn't kind of get that much of a thing done other than sending an email or so. So because of that reason, since everything was kind of clustered out, they had this Arpico, Richard Pettis, they had a mainframe computer, a computer called the mainframe at their main branch. I'm not going to tell you where it was, but they had a computer located at their main branch. And what they do is every day they record all the data to small tape drives. There's a thing called a tape drive. Google search at tape drive. Tape drive it's something like a small device. Podi tape podi tape device record කරන්න පුළුවන්. So it's basically data. So what they do is every day they record all the transactions to one of these tape drives, and one person literally takes it back to the head office and they back it up. That is how they did the stocks. ඉස්සර කියන්නේ ගොඩක් ඉස්සර about yeah that was about 20 years ago when they were like taking new stock in, that for them to allocate a number for that particular stock, it takes about 2 days. That's because somebody literally enters that into their stock taking system. ඒ කියන්නේ දැන් stores එක තියෙනවානේ, stores එකේ system එකට අරගෙන enter කරනවා. දැන් stores එකේ system එකයි අතන system එකයි connect කරලා නැහැ. මොකද අපි internet තිබුණේ නැහැ. තිබුණාට slow. So you can't basically transfer gigabytes of data. So what they did was they literally offloaded everything to a tape drive and somebody takes it back to the computer. අන්න එතන තමයි mainframe කතාව ආවේ. එතන ගිහිල්ලා ඔන්න දැන් තියෙනවා ලොකු computer එකක්. They plug that in and then they offload it into the mainframe computer. So that is the reason we had this thing called mainframe computers. But now when we got into cloud computing, things got changed. Things like drastically got changed because now everything is interconnected and we have fast internet, and there is no reason for us to like store data at a single location. You can easily store data to the cloud and it will be immediately accessed. It can be immediately accessed throughout the world at any point, at any time, and without any cost. Because yes, obviously there's a cost, but then again, the cost is drastically reduced because you don't manage in-house computers. Okay, but keep that in mind. So that's the reason we had these things called mainframe computers back in the day. Then the server farms, cloud computing farms, but we don't call them mainframe computers now, unless if it is some sort of a, as I told you with this Apico example, unless if it is some sort of a specific machine created for a specific need, then that can be called as a mainframe computer. Then we get into the top tier of mainframe computers. So these are called supercomputers. Supercomputers are the most powerful computers capable of processing enormous amounts of data at incredible high speeds. So supercomputers, there are like multiple supercomputers which were invented by IBM, which basically challenged humans on with playing chess with them and so on and so forth. So everybody is basically trying to build the next supercomputer. And if you guys are like keeping tabs on the new quantum computing thing, there's like every day there's new news saying somebody claims that they have cracked the code and they are building the fastest quantum computer in the world. So there's a big competition going on. Google, Amazon, Microsoft, and all these guys are basically competing with each other, trying to build the fastest supercomputer, fastest quantum computer in the world. Kavadari hadai, and හදපු දවසට තමයි හොඳ වෙන්නේ. හොඳකට හැරුණොත් හොඳයි, නැත්නම් ටර්මිනේටර් වගේ දෙයක් තමයි වෙන්නේ අන්තිමට. මොකද last time when Google released their quantum computer details, they compared it with the Intel i7 fully spec'd out machine. So that particular machine, a calculation which takes, I think 99 years or so. So they ran a calculation which will require 90 days or 99 years on the i7 machine. So that particular calculation, when you try to run it on an i7 machine, it basically takes about 90 I think 90 days or 9 days. Okay. The supercomputer runs that in I think about 2 seconds. I'll share that article with you guys. So just imagine the speed. So i7 එකක දවස් 10ක් යන එක අරගේ 2 seconds වලින් process කරනවා. අපිට එච්චර processing power එකක් ගන්න කියන අපිට ඔයාටයි මටයි අපිට use කරන්න බෑ එච්චර processing power එකක්. අපිට කරන්න දෙයක් නැහැ ඉතින්. එච්චර processing power එකක් තියන. But then again just imagine all the possibilities and things you will be able to do. කොරෝනා වගේ ලෙඩක් ආවොත් මෙහෙම කරද්දි solution එකක් ගන්න පුළුවන් ඒකට. ඇයි මොකද genes and cell processing can be done instantly. Right? So those type of things can be good. So there are like both sides in that coin. And okay, so that is called the supercomputers. And then we have this thing called microcomputers. So this is again based on the size. So based on the size, we have the microcomputers. Microcomputers are literally small computers, which is already inside your tablet or inside your phone and so on and so forth. So it's basically a personal computer, which will do all its activities, but it's a miniature version of it. And then we get into mini computers. So mini computers are basically computers which has more power than the microcomputers, but smaller than mainframe. So it's kind of like a PC. So this is similar to a Raspberry Pi. I can show you guys a Raspberry Pi. So I have the same thing here. So this is a small Raspberry Pi. You can remove there's a case with it. So what you can see here is this is the circuit of a Raspberry Pi. So here you can see the microcontroller. So this part is the CPU, which has the this part is the CPU, which has the heatsink, and this is a complete. Basically, this is a complete computer. This has HDMI, two HDMI ports, which literally returns 4K, and you have the power, and you have a USB-C to basically power this up, and you have these ports here. Okay, so I have put the picture of a Raspberry Pi here as well. So this is the same thing. Okay, so these falls under the category as mini computers, which can literally do about all the activities, but the size is small. So it's kind of like a pocketable size. Okay. And then we have the mainframes. So mainframes are like simply these are servers, which is literally created in a way so that it acts as a cluster of servers or a collection of servers. So it's basically created in a way so that you can scale up as much as you want, and it is reliable and its ability to handle extensive data processing and storage. So literally when it comes to a data center like that, you have the option to scale the number of computers you are using so that it will basically give you the edge and the capacity to increase or decrease the number of computers and computing power. And then again, so this is basically based on the size, supercomputers. So as we mentioned earlier, supercomputers are the largest and the most powerful. And so based on the size, they are massive. So they require a massive dedicated facility, as well as it will basically require a huge set of people and like multiple teams to control this. Okay. Nice. So that is what we discussed about the size and the type. Now we are getting into the interesting part where we discuss the functionality of a computer in relation to the hardware and their interfaces. Okay, so this basically is categorized into 4 different parts, which we have the input devices, output devices, the CPU, and the storage devices. I know you guys know what this is, but we'll just go through it so that it can give you it will give you a clear understanding of what we are discussing about. So going on forward, starting off with the most simplest input device. Guys, remember the names because you get questions where they basically ask you in your paper, it asks you to define input devices, output devices, and all these different types of devices, okay? Input, output, CPUs, and storage. So remember the words because you will need to write this. So the keyboard, it's basically one of the primary input devices for a computer. And then it contains a set of keys, including letters, numbers, symbols, and functions. And it basically works in a simple way where you press in a key and that key is basically that data set is sent to the computer, right? Simple as that. So it's the most basic device, which is kind of like the most primary device as well, because in order to communicate with the computer, you need to feed in data, right? In order to feed in data, the only way of doing that is using a keyboard. Okay, so going on forward. Then we have the mouse. So the mouse is the pointing device that allows users to control the cursor's movement on the screen. It typically has buttons on for performing the actions, such as selecting, dragging, and clicking. And users move the mouse on a flat surface to control the cursor's position and perform tasks efficiently. So we have like multiple different types of mice in the world. You have mice where you just keep it stationary in a location and you move a huge ball, which is called the trackball mice. And you have like when it comes to Apple products, Apple mice, the Apple Magic Mouse, it does not have any buttons, so it's kind of like a single touch surface, so that you can it will detect where you touch on the button and it will take it as a button click. So there are different types of mice, but the most typical one is what you have with 2 buttons. And then you have gaming mice as well, where it will basically have different advantages in using, in the sense sometimes you need to have this high precision DPI, dots per inch range. Like when you move the mouse from one place to the other, if when you have a high DPI range, it will give you a high precision. Okay, so that is why these pro gamers use professional mice, like with the high DPI range. Okay, and at the same time, you have the option of using a high performance keyboard as well, where it will basically let you reduce the latency of a key so that it can give you an edge on that as well. මම නිකන් එක්ස්ප්ලেইন කරන්න මේ පොයින්ට් එකට ආපු නිසා මොකක්ද වෙන්නේ කියලා. දැන් එක්සැම්පල් එකට අපි කීබෝඩ් එක ගත්තාම if you take the keyboard and how it works is now I'll just show you an example. So I have an Apple keyboard here. So this is called the Apple Magic Keyboard or something. So this is wireless. So how it works is when you press in a key, the Bluetooth is literally connected with the Mac machine, and then it will literally send the data from the keyboard to the machine, and then it will be processed. Take a process vela. ඊට පස්සේ ඒ key එක identify කරලා then you get the output on your device. හරි. හිතන්න අපි එන competitive game එකක් ගහනවා. තමු Counter Strike ගහනවා කියලා. Counter Strike වල Counter Strike එකේ if you are playing with an opponent who has like high end gear, මේ key එක press කරනකොට මේ keyboard එකේ button එකක් press කරනකොට there is a delay. How it works is like that particular delay which it takes to send the data and your character on the game to react, it will take couple of microseconds. Right? That microseconds can ruin your game. හිතන්න දැන් මම ඉන්නේ pro keyboard එකක කියලා මගේ pro keyboard එකයි මගේ normal keyboard එකේ ගහුවොත් දැන් මේ Apple keyboard එකත් එක්ක play කරොත් Apple keyboard එක හැරෙනකොට අරයා තියලා ඉවරයි. මොකද එයාගේ latency එක අඩුයි. Okay. So that is something, that's the reason people move on with high-end devices. And when we were small, we did not had all these devices. So අපි පාවිච්චි කරේ මොකක් කරේ අපි සබ හොඳ mouse එක පාවිච්චි කරා. ඒ කාලේ 800 dpi කිව්වහම අන්න පොරක් සෑහෙන්න පොරක්. Now I think you have about 4000 dpi is normal. I am using one here. It's Logitech G40 something. I think this one is 12,000 dpi. So having these type of mice, it will basically help you is like make it easy to work, as well as it kind of gives you an edge. So this delay and all, remember to follow up these points. So back to the input devices. So we discussed keyboards and mouse, and then we have the touch screen. So the touch screen, obviously, we all know what this is. It's basically a screen where you can touch, and when you touch on that particular location, that input is taken and processed in the system. So just keep in mind, there are like two different types of touch screens. One is basically the capacitive touch screen, which is like the phone touch screen which you have on your mobile devices, and the other one is force touch screen, where it will basically take the force on the screen, and there are like different panels which will detect it, and then that will be taken as a touch. So usually this අපි ඔය කියන්නේ පරණ ෆෝන් වල touch එක යනවා කියලා touch වෙන්නේ නැහැ කියලා. පරණ phones, most of the old phones, they basically use this other type of touch system. So because of that reason, like in time, that panels get worn out, so that automatically the touch sensitivity goes down. But when it comes to the new phones, we don't have that anymore, because all the new phones are basically using the capacitive touch system. So yeah, that's about the touch screens. And then so then we have the trackpad. So the trackpad is again falls under the input device. So the trackpad is basically mostly commonly found on laptops, and there are some desktop computers as well where you can literally buy trackpads, and you can plug it in as a mouse. But end of the day, the trackpad, still the functionality is 100% similar to a mouse, but it will give you more surface to interact with. So a mouse is basically a device where you hold it with your hand and you have to move your hand. But here in this case, you get a wide surface where you can use your finger as the cursor, so that the precision is higher compared to a mouse. The mouse කිව්වට ගොඩක් අය මාත් එක්ක ඕකට අරගන්නත් පුළුවන්, මොකද සමහර අය කියනවා නෑ mouse එකේ precision එක වැඩි කියලා. ඒක ප්‍රැක්ටිස් කරපු එක්කෙනාගේ යූසේජ් එකේ හැටියට ඒක වෙනවා. දැන් සමහර අය ඉන්නවා මුල ඉඳලාම touchpad එකක වැඩ කරපුවා. So I have pro level video editors and graphic designers, couple of my friends who does not use a mouse, who basically, like, some people have two trackpads to handle different buttons. So you have both the options. You can either like, when you get used to it, it is actually quite easy. But mouse එකට පුරුදු වෙච්ච කෙනාට mouse එකත් lazy. හැබැයි ওই දෙකටම වඩා මේක තමයි lazy, using a graphic tablet. So the graphic tablet is basically a touch, like a touch panel, but more advanced, where you can use a pen. So it's basically same as a trackpad, but it will only detect this particular pen's tip, so that you can use that pen to draw whatever you want. අපි කොහොමත් අර පෑනක් අල්ලනකොට අපිට ඒකේ තියෙන precision එක වැඩි වෙනවානේ. So when we hold a pen like this, obviously we are used to write, right? So since we are holding the pen in this particular similar way, it's going to give us more precision when it comes to writing. So graphic tablets, they are being like mostly being used by graphic designers, architects, sound engineers, and all these people, all these creative guys. So functionality is similar to a mouse, but it's more precise, allowing the user to control the cursor. Okay. Then we get into the next input device, which is the scanner. So as you guys know, scanner is basically there to scan a physical document or a photograph or an image into a digital format. What it does is it works in a similar way as you have your sensor in your mobile phone. So it basically takes a couple of screens when it's moving from one place to the other. So it captures part by part. It captures content part by part, but the accuracy is where it automatically gives you a controlled light, and it allows you to have a clear view about, it allows you to get a clear output since that light is being illuminated during the full scan process. So if that light is not there, then you're trying to do the same, you're trying to take the same picture using your mobile phone. If that light is not there, obviously your photo will not have accurate lighting. I think එක තැනක් අඩු වෙන්න පුළුවන්, තව තැනක් වැඩි වෙන්න පුළුවන්, කොහෙන් හරි ඉඩක් එන්න පුළුවන්, shadow එකක් එන්න පුළුවන්. So all these things are eliminated by having a base light, as you guys can see in this in the video, where you have the light illuminating the document and then it scans for the entire period. So that's about scanners. And then we have the webcams. So we are all familiar with the webcams, with the issue we had during the past few days. Past few years, we got into we started using webcams a lot because everything moved back into the online thing. So obviously we know why and how to use this. And most of the laptops comes inbuilt with a webcam as well. And it's basically there to capture video. And then we have the microphone. So we captured keyboards, key entries, mouse movement, scanned, and then video capturing. And then we have the sound capturing, which is basically the simplest device called the microphone, where it will allow you to record audio and voice as an input. And it will also allow you to control or give commands to a PC using voice commands as well, because that will literally act as an input device. Then we have a couple of other things as well. So these things, these items were not there in your, these three items were not there in your course curriculum, but I am in your A-level curriculum, but I am going to explain this because just keep in mind, Metunat important. This also has to be kind of, you guys need to know what this is. So joysticks and gamepads were there, but the next two items were not there. So we'll go through it again. So joysticks and gamepads. So joysticks and gamepads are input devices designed literally for gaming. They allow users to control movement and perform actions in games by manipulating buttons, thumbsticks, or directional pads. Now, yes, it is being used for gaming, but is that it? Gaming විතරක් නෙමෙයි නේද? අපි දැන් game pads use කරනවා හැම දෙයකටම. So the one of the main use cases are like drones and all. So you basically connect your gamepad into your PC and then you use a transmission control, and then out of the box you can use your drone, or you can pilot your drone using the gamepad. Simple as that. Okay. So there are multiple new use cases invented by the new systems being released as well. So then we have that's about the gamepads. Now we have the important point where barcode readers and scanners. So barcode reader works in a similar way like as the scanner. Like, so we discussed about the paper scanner. So what it does is it basically illuminates the light, and then it has a camera where that camera will capture whatever that light reflects, right? That is how the system works. But when it comes to barcodes, it works in a different way. So the barcode reader does not need to illuminate any light into an object to read it. So how this works is it has a small laser light set, a light set similar to a laser, where it will keep on blinking. So how it works is when some sort of an object comes in front of it, when that light is disturbed or when that light is broken, automatically the system is able to read that barcode. So in a barcode, what you have is literally a set of numbers. That's it. Simple as that. And when you run the system, when you scan it, you need to have a database where it will have all the data which refers to that particular barcode value. In the sense, now, example, a barcode can have set of numbers, let's say 0, 0, 1, 2, 3, 4, 5, 6. That's the number. So when you scan the barcode from your whatever the barcode scanning device, what it will do is it will literally give you that number. It will show you as 1, 2, 3, 4, 5, 6. Then you need to implement a system so that it will check a database or some sort of a location and find out what is related to 1, 2, 3, 4, 5, 6, and then it will show you the details. So it's basically one of the most used input devices when it comes to companies, factories, storage systems, even any grocery store or any supermarket basically have the barcode reader system active, because that is how they track their systems and that is how they track their stocks and so on and so forth. So keep that in mind. And then we have the biometrics. So biometrics is also one thing which is really important. biometric devices. We call a device a biometric input device if it will literally scan a physical characteristic of a human being. බල්ලෙක්ව ගන්නත් පුළුවන් අපි example එකට අපි humans ලා කියලා ගමු. හරි. So as long as it will scan a specific physical characteristic. In the sense, it can be your thumbprint, it can be your facial expression, it can be your eye, or it can be literally be your full face as well, where it will scan that and then we can use it for multiple use cases. Number one, the simplest use case is for authentication. Give me 1 second. Where we basically use this for secure login, control access to a specific location, or for identification purposes. So as you guys, I'm not sure whether you guys are familiar with it. So there are these things called biometric keys. So we use it time to time. So you have the thing called I don't have anything to show you guys right now with me. Otherwise, I would have shown you an actual device. So it's kind of like a small pen drive where at the end of the pen drive, you have a fingerprint scanner. So how you do is you need to install it with an application, or you can just plug and play as well. And let's say when you go into facebook.com, when you try to log in, all you need to do is just open facebook.com. You have to authenticate and trust the device. Once you trust the device, all you need to do is just put your thumb on the scanner and it will automatically authenticate you into the website. So just search for items like YubiKey or biometric keys. You can actually buy, like there are like keys you can buy through eBay as well. මම දන්නේ කොච්චර හොඳට වැඩ කරනවද කියලා, but do you have like there are keys available to buy from those platforms too, where it will literally let you scan and use your biometrics to authenticate. So why do we use it? Mainly for security, and at the same time, when it comes to server-side applications and like secure applications, we use biometric keys to lock them out. And there are like different biometric combinations as well. The biometrics use karnawata, there are ways where you can create a combination lock. Example eකට හිතන්න අපි දැන් අපි හතර දෙනා ඉන්නවා. අපි හතර දෙනාට keys හතරක් තියෙනවා. හරි. අපි හතර දෙනා මොනවා හරි ලොකු system එකක් හදලා දැන් හිතන්නකෝ මොකක් හරි වෙන high end app එකක් හදලා ඒ application එක අපි හතර දෙනාගේම keys හතරෙන් protect කරනවා. So that means all four of us will use our thumbprint, and then that particular code base will be protected under our thumbprint, or that application will be protected our thumbprint, and it will be encrypted using that keys. So we distribute this, we keep all these 4 keys with us, and it's like completely secured. හිතන්න අපි keys හතරක් කොහේ හරි ගිහලා හංගනවා. ඒ කාටවත් හොයන්න බෑ. So unless the person who wants to steal this have the key and have this thumbprint, they won't be able to capture the information. So this is something which most of the companies, like most of the high-end security companies does, where they basically use these keys and they store the key in a different place and they store the person in another place. So just to make things may be high, like to make things secure as much as possible. Okay, so that's about input devices for biometrics. And then we have the that is about okay, now then we have the output devices. So output, mainly we have the monitor. So the monitor is also known as the display or the screen. And this is the primary visual output of a system or of a device, right? And then it basically presents text, images, videos, and graphical user interfaces in a visual format that the user can basically perceive. See, in simple terms, අපිට මොකක් හරි එකක් බලන්න පුළුවන් UI එකක් return කරන්නේ display කරන්නේ monitor එකේ. So monitors comes in multiple different types. So you have the monitors such as LCD, LED, or OLED, which comes in various sizes, resolutions, and types. So now we are not talking about the CRT monitors, which is also known as the cathode ray tube screens, which is the old generation of screens or displays which we used a couple of years ago. Couple of years can ලොකු කාලයක් නෙමෙයි මම හිතන්නේ 2005 තුවා තිබුණා. I think so. And yeah, I switched to a LCD. I switched to LCD monitor in 2006 until 2006 වෙනකන් I was using a 21-inch CRT monitor. ඒ monitor එක කොච්චර බරද කිව්වොත් මගේ computer desk එක මෙහෙම තිබුණේ. Computer. So the monitor was, I think, monitor was somewhere about 20 to 30 kilo, about give or take 15 to 20 kilos. So with time, the computer desk basically went down and it kind of warped into a kind of like a wrong shape because of the weight of that monitor. And when I bought the new LCD monitor, I had to change the desk as well, since that was entirely warped. So that was with the old time with the CRT monitors, but now we don't have that anymore. So now we have the OLED, and I think the latest one, the latest one is called micro LED, MLED, micro OLED, I think, micro organic LED, which is the latest one, which was recently released by Samsung. So it's kind of like a more condensed version of LEDs. So the quality is much higher compared to a typical 4K screen. So yeah, that's about monitors. And then we talk about the printer. So printers, obviously, simple as that. You guys know what this is. It's there to print just a simple hard copy of a digital document or images on paper. So they come in different types, including inkjet, laser, and all-in-one printers that perform scanning and copying functions. And printers are commonly used for document, photo, and other printing needs. So these inkjet and laser printers, they both work in two different ways. So the inkjet is basically a printer where it uses ink, and what it does is it kind of sprays the ink on the paper itself. So that is how the ink is being printed out or printed to the paper. Otherwise, how it works is the laser printer works in a different way, where it kind of fuse the color or that particular black ink or the colored ink using a magnetic and a heat process, so that it will fuse the ink with the paper. So when it comes to longevity and quality of the print, obviously laser printers are good compared to inkjet, but then again, there are inkjet printers where you will have high DPI range printer heads, where you can literally print high quality photo quality paper as well. ඔය මේ weddings වල ගහන්නේ මේ weddings වල ගොඩක් මේවා කරන්නේ ඔය thank you cards එකෙන් print කරලා දෙන්නේ ඒ වෙලාවෙම. So that's technically a inkjet printer which where they use the photo without using the typical paper. They use photo paper to print the photo. That's it. So it's cheap and effective as well as fast. And laser printers, obviously, it is expensive. And quality-wise, yes, but price-wise, it's really expensive. So I just explained you the background of that. So then we have the speakers. So speakers are the audio output device that produce sound generated by the computer. And they allow the users to hear music, video system sounds, and all other content. So some speakers can be built into the computer, as well as you have external speakers, which will be connected to the computer using cables. On top of all these things, we have wireless speakers as well, which is currently now the trend. Now we don't use these wired speakers anymore. Now almost everything has become wireless speakers using the new Bluetooth technologies. And then we have the headphones and headsets. So this is again a simple speaker, but it's focused towards personal audio, where it will be something where you wear. So sometimes it consists of one speaker, and sometimes it goes with two, where it will basically cover your ear, providing an immersive experience. So headphones and headsets, for the past few years, they came a long way from what we had it back about 5-6 years ago. Because when Apple released their new headsets, they introduced different features in it, like spatial things called spatial audio and sound detection engines, and their own. I think during one of my last lectures, I showed you guys the Apple headset microcontroller, where they literally created a CPU and placed it inside the headset itself. So with all those things, they came up to a new standard. So that is why this is one of the most important output devices as well. And then we have the projector. So you all know what the projector is. It's simply the display part, where it will basically let you print out show a display page. And then yeah, this is something extra which I added to the slides, which is called a braille display. So braille is actually the way blind people read. So braille is technically a language where you basically get a piece of paper and you punch it, and you basically learn how to move your fingers on top of these punched lines and designs, so that you can automatically translate that into text. So that is how a blind person reads something. Okay. Now with the new technologies, now we have braille displays, where a blind person can literally touch a screen, something like a touch screen, and they can feel and read what is there. So now, until this time, people had to literally print books in Braille language, where a normal person will not be able to read it unless they know how to read Braille. So that was the way it was created, like content was created for them. But now with this Braille displays, you are able to move your fingers on top of it, and you can read it. So this is something new, and just keep in mind that this is also available. Okay. And then we have another item which was not there in your initial A-level curriculum list. So we have the 3D printer. So the 3D printer is again an output device which will basically print an 3D object using plastic ink, something like a plastic plastic material where it will literally print the design on top of a base according to the system you provided. So it can literally produce three-dimensional models, prototypes, and functional parts. And it basically finds applications in various industries, including manufacturing, product design, healthcare, and education. So recently, somebody started printing human organs as well. So there will be some time where we will be able to get our body parts printed as well. So this is something which is being experimented and explored very widely. So then we have the other output device, the next one, the last output device on the list, which is haptic devices. So these haptic devices provide tactile feedback or vibrations to enhance the user's interaction with digital content. The best example is if you guys have played, or if you guys have a PlayStation 4 or a PlayStation 5, starting from PlayStation 3, first PlayStation, it was there. So that particular controller, when you, let's say, when you're playing a game and if you get hit by someone, or if you get hit at a location, let's say you're playing a car game or let's say a fighting game, when you take a punch, automatically the controller starts vibrating so that it will give you a tactile feedback with the vibration so that you can understand how something happened. Likewise. So they can simulate touch sensations, textures, and forces, adding the sense of realism and immersion. So this is the same thing which we have on our mobile phones, where when you press something, you have this internal vibrate of the phone, and it vibrates and gives you a tactile feedback. Let's say when you type in your phone, every time, if your keyboard is enabled with that tactile feedback thing, when you type in a message, every time when you press a key, that will start to vibrate and you will get the feedback. So this is again one of the most important output devices where it will literally give you a realistic feedback so that you know what is going on. Okay, perfect. So then we get into the next point. So we have a few more points to go, but yes, so we'll start from this. So we get into the central processing unit part. So the CPU, central processing unit, is also referred as the brain of the computer. අපි සාමාන්‍යයෙන් එහෙම තමයි කියන්නේ. මොකද ඒකනේ main point එක. So it's a crucial component responsibility of executing instructions and performing calculations and coordinating the activities of other hardware and software components. Literally, ඒක තමයි මොලේ වගේ තියෙන්නේ computer. මොකද ඒක තමයි ඔක්කොම අපේ data points ටිකයි hardware points ටිකයි capture කරලා execution එක යන්නේ. So the CPU consists of several vital parts that work together to carry out these functions. So we'll get to the functions and see what are the functions. So you have the control unit. So the control unit, so what we are going through is we are going through the points of the CPU so that you guys can easily understand what it basically does. Okay, so we start from the controlling unit, which is also known as the CU. Controlling unit is basically the part where it coordinates the operations of the CPU. Operations කියන්නේ නිකන් හිතන්නකෝ මෙයා තමයි උඩම ඉන්න එක්කෙනා හිතන්නකෝ we are stuck in a huge traffic jam and there is one police officer who is there who basically controls all the traffic. He says අන්න මෙයා ඇවිල්ලා ඔයා මෙතනින් යන්න. මෙයා මෙතනින් යන්න. මෙයා මෙතනින් යන්න. හරි. මෙතන කවුද එනවා? එයාට ඉඩ දෙන්න. That particular part is done by the police officer when it comes to a traffic jam, right? So just think this something similar to that, where the control unit will literally fetches the instructions from the memory and interprets them into determining the task to be performed. memory එකේ ගිහිල්ලා බලනවා හරි. මෙයා මෙන්න මේක කරන්න. ඒක අරන් ඇවිල්ලා මෙයා තමයි මේ flow එක හදන්නේ. So the control unit controls the flow of data and instructions between various components. Then it starts processing. Okay. So when the instructions are sorted out and when the tasks are clear, then we get into the arithmetic logic unit, which is the ALU. ALU is the person or the unit where they will literally run the logical operation. දැන් අර ඇවිල්ලා කියනවා මෙන්න 1 1 එකතු කරන්න කියලා ඔන්න කෝල් එකක් තියනවා කියලා. හරි. control unit එකෙන් දානවා ALU එකට point එක. Okay. So the ALU goes through it. Okay, I have a calculation. What is this calculation? It's an addition. It basically goes through this and it adds 1 1 and it gets the arithmetic, that particular value out. Simple as that. Hari control unit එකෙන් මොකද්ද කරන්න ඕනේ ගෝ මෙන්න මෙයා process කරා. Now what? So now it's processed. Now we get to the next one. So now we need to basically store this at some point, right? දැන් මේක පාවිච්චි කරපේක store කරන්නත් මොනවද process කරේ කියලා. That is where the registers comes in. So the registers are small high-speed storage units located within the CPU. So this is not storage in the sense, this is not storage, data storage. So this is kind of like a storage unit which will store instruction. Okay, and an intermediate result during the processing. දැන් හිතන්න අපි 1 1 එකතු කරන්න කිව්වා. හරි. 1 දාගත්තා 1 දාගත්තා එකතු කරලා 2යි කියලා දාගත්තා. So that's the intermediate state of the processing process, right? So that is where it's being saved on the register. So registers enable fast access to frequently used data so that it will kind of improve the CPU's performance. So now we got the instruction, we processed it, now that is saved. Then we get into a more high-speed memory where we will be able to store it so that it will reduce the CPU overhead overall. So what this does is it's kind of like a small but high-speed memory located within the CPU, or it can be near it. සමහරවිට CPU chip එක ඇතුළෙම තියෙනවා. Sometimes it comes as an external unit or a device for the CPU. So what it does is it stores frequently accessed data and instructions to reduce the time it takes for the CPU to access the information from the main memory. දැන් අර part එක ඉවරයි. process කරා ඒක ඉවරයි. හරි. cache එක කරන්නේ මෙහෙමයි. cache එක තියෙන්නේ now if you try to read something හිතන්න මෙහෙම එකක්. So example අපි ගමු game එකක්. හරි. So we are playing a game and in that game there are multiple assets, right? We have images, we have sound, we have activities and so on and so forth. So how it works is usually when you execute the game, that game will offload the assets which will be used mainly to the memory. Memory in the sense RAM eකට. RAM eකට offload කරනවා. So when that is offloaded to the RAM, then let's say there's a session, there's a time where you have to process a specific image or a specific action within that game. Then how it works is control unit එකට යනවා අන්න මෙන්න මේක execute කරනවා. Then the control unit goes through the entire process to find what is required to be processed. And then just think if that control unit has to go all the way back to the memory. The RAM එක එළිය වෙනම ගහලා නැති RAM එකට අවිල්ල ඕක අරගෙන යන්න ගත්තොත් ඔතන ලොකු delay එකක් එනවා, right? Because the control unit is processing and it goes back to the memory, to the RAM, and it goes through all the memory points and then it finds what is required and it comes back to the CPU to process it. So in order to bridge that gap, we have the cache memory. So cache memory, what it does is, this basically gets the instruction set, which says, okay, මට ඕනේ ABCD process කරන්න. Immediately hits the RAM and takes that particular ABCD chunk of data and cache it in the cache memory. Then cache memory එකේ තියෙනවා බඩු ටික. ඊට පස්සේ cache memory එකේ තියාගෙන මෙයා process කරනවා because the cache memory is extremely fast compared to the RAM and it is located very closely to the CPU itself. So the transfer time is extremely low, less to nothing. So because of that reason, it keeps everything on the cache. You guys can and must and should notice that when you take a CPU, it basically shows you a specific information set, and in that information set, it should show you a couple of cache levels like L2 cache, L3 cache, and so on and so forth. So higher the cache CPU has, the performance will be high as well because it will have more capacity to store the data and process it. Okay, so that is how it works with the caching point. And then we have the instruction. There's a thing called an instruction pointer. So this is kind of like a special register which keeps tracks of the memory address and the next instructions to be executed so that it will be executed in a correct sequence. My instruction point so just keep this in mind at the moment, but we will, when we start Python, when we are starting Python and when we start the coding part, we'll get to this because I will show you guys how to create pointers and how these registers work. Because එතනදී තමයි මේක ඇත්තටම ඔයගොල්ලන්ට හරියට තේරෙන්නේ. මොකද තාම මේ අපි නිකන් තියරි ගන්න කතා කරන්නේ, මේ තියරි එක කතා කරන්නේ මේක ඔළුවට යන්න ප්‍රමාණය සෑහෙන්න අඩුයි. So that's the reason I'm kind of doing this kind of like a really interesting type of a presentation so that you guys will get the idea. You guys should get the idea. But we'll check the actual usage of this when we go into the programming part. So then we have the bus interface. මේ bus එක තමයි මං ගිය පාර lecture එකේ I showed you guys about this components of a motherboard, right? Can you, if you remember, I showed you guys that there are two controlling points in a motherboard. You have the north bridge and you have the south bridge. So the south and the north and the south has different responsibilities allocated to them, where one bridge is responsible of controlling all the input output and another chip is responsible of controlling the CPU and all these other related hardware. So all these communication points are literally connected through this interface called the bus. It's also known as the BIU, bus interface unit. මේක ඇත්තටම බස් එකක් වගේ තමයි වැඩ කරන්නේ. මේක වෙලා තියෙන්නේ මෙයා තමයි data ටික ගෙනියන්නේ. මෙතනින් අතනට ගෙනියනවා, අතනින් මෙතනට ගෙනියනවා. ඒ data part එක හදන්නේ මෙයා. So we discussed that we have the universal serial bus, the protocol, so USB protocol, which is again a communication protocol which will be, or which is being used to communicate data. So bus interface unit handles communication between the CPU and all the other components of the system. And it manages data transfers between the CPU and the memory as well. And the bus interface unit controls the data flow along the system bus, ensuring efficient data exchange. ඔතන තමයි ඔක්කොම data flow එකයි ඔක්කොම controls ටික වෙන්නේ. So that is one of the major components which will basically let you interact with the system. Then we get into the clock. මොකද්ද මේ clock කියන්නේ? මේ clock එක තමයි ලොකුම කතාව. Clock එක වෙන්නේ, so when the CPU is executing, just think like understand this in a very simple way. හරි. හිතන්නකො clock එක කියන්නේ cycle එකක් කියලා. මෙහෙම pulse එකක්. හරි. So this is a pulse. So every time when something needs to happen, you need to have a pulse. Okay. So this pulse is a specific frequency which is defined in the CPU itself so that everything will be synchronized according to this particular cycle. ඔය cycle එකට තමයි අපේ මුළු හැම CPU එකකම හැම processing එකක්ම වෙන්නේ. So this is the pulse speed, which is also known as the hertz of the computer. අපි කියන්නේ 3.5 gigahertz, 4 gigahertz, multi-core, multiple gigahertz points, so on and so forth. So that is how this is being defined. So this is actually something which goes extremely in-depth into the hardware architectures of CPU. So I'm not going to go in-depth, but I'll just simply get the idea. So it's basically generating a regular pulse, synchronizing the operations of various components within the CPU. Processing එක කියන්නේ එක clock cycle එක. එහෙම clock cycles ගොඩක් ආවම multiple processing එකක් හදන්න පුළුවන්. So, a review. So, all these parts work together to enable the CPU to execute instructions and perform calculations. So, the control unit fetches the instructions, the ALU performs the operations, registers and cache memory stores the data, the instruction pointer keeps track of the next education or the point which is required to be executed. The BIU, the bus interface unit, handles communication, and the clock ensures synchronization. තේරුණාද වැඩි? control unit එකෙන් ඔක්කොම ටික details ටික ගන්නවා. මොකද උනේ කියලා බලනවා. ALU එකෙන් මොකද වෙන්න ඕනේ කියලා බලනවා. ALU එකෙන් මොකද්ද වෙන්න ඕනේ කියන එක බලලා එයා process කරනවා. registers cache එකෙනුයි ඒ data ටික store කරලා තියාගන්නවා. instruction point එක තියාගන්නවා දැන් අපි කොතනද ඉන්නේ කියලා. දැන් හිතන්න අපිට control CPU control unit එකට එනවා ලොකු data set එකක් process කරනවා. හරි හිතන්න activities ගොඩක් එනවා. instruction අපේ instruction point එකෙන් තමයි තියාගන්නේ හරි මම මෙතන හිටියේ. Okay, so I have processed this is next, this is next, this is next, likewise. That keeps the track of the next point, and then the bus will literally handle the communication. Then process කළ මොන හරි යන්න ඕනේ කියමුකෝ. හිතන්න අපි RAM එකට ගහන්න ඕනේ මොකක් හරි data set එක. Then the bus will handle that particular part, and the clock will ensure everything is synchronized and will be executed in a specific clock cycle. ඕක තමයි simple විදිහට CPU එකක වෙන්නේ ඇතුලේ වෙන දේ. That's the typical flow of a CPU in a explained in a simple way. Okay, so the CPU's performance and capabilities are influenced by the clock speed, because that's the speed a transaction or a processing can happen. So the number and size of registers, cache sizes, and overall architecture of the so it's influenced by the clock speed, or as well as it is obviously influenced by the number and size of registers, cache sizes, and the overall architecture of the performance as well. So mainly speed එකට අමතරව cache size එකත් ගොඩක් important, because that is why they say like all these high-end games and all, they require you to have a processor with a higher clock speed as well as a higher cache register, so that it can basically have more performance in it. Okay, super. So we covered up CPUs. Now we have few more items to go forward, and then it will be done for the day. So what is it? So we are talking about the storage devices. So what is the storage part? A storage device is literally a way where we store some required information in your device, in your computer itself, right? So there are multiple different types of storage devices. What you can see here is literally actually a hard drive, an opened hard drive, where you have this spinning disk. You guys can see that the disk is spinning and that arm is trying to read it. Okay, so These are the most widely used storage devices in computers because they use a magnetic storage architecture, and it is being saved in rotating metal platters. So basically all the magnetic points, so using a magnetic system, same as using these tapes, it writes data onto these rotating metal platters, and then the system or the hard disk can convert that data into binary, and you can easily read it. So these hard disk drives, HDDs, or also now we call them spin disk drives, they provide large storage capacities and are commonly used for storing operating systems, software, files, and multimedia content. So now it's not commonly used for storing operating systems because now hard disk drives are considered as slow drives. And now people are moving towards solid state drives, which is much faster. And when it comes to operating systems, you are like literally recommended to install your operating system on a solid state drive so that it will give you an edge when it comes to the speed. So this is how it works, and then we'll get into the next part, which is the solid state drive. So SSDs are like becoming extremely popular now, and it is actually a common device which is being used by almost all the computers, inside all the computers. So unlike hard disk drives, SSDs do not have any moving parts in it, and they use a different architecture similar to flash memory drives, which is similar to our pen drive. There's a certain, let's say, a certain specific lifetime when it comes to these SSD drives compared to the hard disk drives, because since there are no moving parts, obviously wear and tear wise, it is really low. But SSDs has a thing called a data cycle where you can have you can, or it is limited to a certain number of read and writes. So if you go past that particular number of read and writes, then obviously that will not it will stop working, something like that. So you just need to keep that in mind. So SSDs offer faster data access and transfer speed, making them ideal for operating systems, applications, and frequently accessed files. So SSDs are the next code choice you have. But anyway, when it comes to like typical hard drives and storage, obviously going forward with the SSD would be the best choice because that is going to be faster. Technically speaking, and hard disk, the transfer rate of a hard disk varies from 3 GB to 3 GB per second to 6 gigabytes per second. And when it comes to an SSD and high-speed SSD, M.2 SSD, which can go up to about 30 megabytes per second, 30 GB per second, or 30 gigs or something like that. So it is like quite fast, and performance-wise, it's extremely good. Then we get into USB flash drives. So we all know what this is. It's called the thumb drive, and it's a portable storage system where you can easily plug it into a USB port, and it will give you a convenient portable way to keep the data stored. Then we have the optical discs, which is now a spin type disc, which is also known as CDs and DVDs. And recently we had the Blu-ray disc as well, which has higher storage than compared to a typical CD and a DVD, which this uses a laser technology to literally read and write the data. So they are commonly used to distribute software, movies, games, and backups. And optical discs were basically the go-to choice, which we had a couple of years ago, before we had all the internet and so on and so forth. Optical discs were the norm when it comes to movies and games. So still, when it comes to PlayStation and Xbox and all, still we use discs. So even the PS5 version, PlayStation 5, we still go for the disk. We still go for the disk version as well. Okay. So then we have the next point, which is the next category, memory cards. So memory cards, again, the architecture is similar to the SSD system, where it basically store the data using the same flash architecture. But the fun part is memory cards are like, so these are called compact flash cards and SD cards, secure digital cards. So there are two different types. So both works in a similar architecture, but the fun part is the size is really small, so that it kind of allows you to use this cards in removable devices like video cameras and digital cameras and all. So it allows you to have a certain memory limit, but now with all the new technology advances, now you have memory cards which goes up to about 256 GBs. So that's good, and it is small and portable. So you remember, this also falls as a storage option. And then we have the network attached storage, also known as NAS. So a network attached storage is a dedicated device or can be a server which is connected to a computer network. So it provides a centralized storage accessible by multiple users over the internet or over the network or over the internet. It can be both. And NAS devices are often used for data backups, file sharing, media streaming, and remote access. So NAS systems, people have that almost, people use it all the time. Even I have a NAS at my home created using a Raspberry Pi, so that it is connected to my home network. And I have some downloaded movies on that, so that when you, I can access the NAS, the network storage, through my Wi-Fi network, so that if I download a movie, then that movie will be copied, or if that particular video will be copied into the NAS, and I can access it through my TV. Likewise. So that's the typical usage of a NAS at your home. But then again, when it comes to office spaces and online systems, we use network access to storages to basically share data within us. So it's again a simple machine with a couple of hard drives attached to it. And the simplest thing is it has its own operating system to handle the storage, and it's connected to the internet or to the network, so that you can have your own file base and save things on the file, so hard drive itself. Then we have the cloud storage. This is again the next step of network access storage, where all your data will be saved on the cloud, which you can access remotely through the internet. So it basically gives you a flexible and scalable storage solution that can be accessed from multiple devices, as well as the cloud storage service offers various plans and storage capacities, making storage and syncing files, backups, and collaborative work extremely convenient. Okay, so that is it for the storage, and we are done with the slide deck for today. So next week we will be covering up the rest of the parts, which is the parallel and grid computing and the fetch of this the von Neumann architecture, as well as we'll go through the memory hierarchy of a system, and we'll see how different types of memories and how those systems work. Then the introduction to computer, the second module, will be done from after our next class. Then we get into some interesting points, interesting modules, which is data representation, where we will be discussing on numbers, characters, and all these arithmetic units and all. So yeah, that will be the flow. And thanks a lot for joining today. I will upload this video to YouTube in a while so that it can be shared by others as well. And yeah, super. Thanks for joining. See you next week then.